Hello students. Today now we are going to discuss about the concept of electric field. So concept of electric field. What does it mean? Electric field may be defined as the region or space around a given charge. This is a given charge. It has a tendency to attract or repel any other charge. So the extent or the spread space around this charge within which any other charge can experience a force of attraction or repulsion, that is called as the electric field. Say this is that region within which it can attract or repel any other charge depending upon the charge, whether it is positive or negative. So that region is considered to be the electric field. So how can we define the electric field? It is the space or region around a given charge within which its force of influence can be experienced by any other charge. Now remember that this space, in this space when we are placing say a charge plus q, so this is causing its attraction or repulsion on any other charge, say q naught. This q naught is termed as the test charge and this is termed as the source charge. Now this is the physical concept of the electric field, but mathematically how do we take it? This charge is applying some force on the test charge. Basically we consider the test charge to be a positive charge with very less magnitude. We can say that q naught should tend to 0. It is so small that it is approximately 0, not 0, but we consider it to be so small that the presence of this charge does not influence the charge q. The field, the force of q is not affected by the presence of charge q naught. So we assume it to be very small, infinitesimally small. So this is q naught tending to 0. Now if the source charge is positive, test charge is to be considered as positive. So in that situation there will be a repulsive force. The force on q naught due to q, that should be equal to k q into q naught upon r square, where r is the distance between the two. So electric field strength at q naught we represent it by capital E, and that is identified to be F upon q naught. That is the force experienced by per unit charge. That means if q naught had to be 1 coulomb, then how much is the field or the force acting at this charge because of the presence of plus q. So this is the electric field intensity. So here we represent a term within the limits when q naught tends to 0. So electric field under the limit q naught tends to 0 is F upon q naught, the force experienced by q naught. So this can be taken as that limit q naught tends to 0, 1 upon q naught into. Now the force we have identified to be k q naught upon r square. So we take it as k q naught upon r square. Q naught is cancelled. So E comes out to be kq upon r square. What does it show? It shows that the electric field intensity is independent of the presence of test charge. It is entirely depending upon the source charge and the distance at which we are identifying the field. Again, the field intensity to a charge is depending upon the charge, the source charge, and the distance at which we have to identify the electric field. Now if we focus on this expression, that is E equals to limit Q naught tends to 0 F upon Q naught. Remember here that F is a vector quantity. We had discussed in the previous video where we represented the force using Coulomb's law in vector form. Q naught is a scalar quantity. So when a vector divided by a scalar must be a vector, but natural. So if it is a vector, so E should also be a vector. So we can represent E vector as force vector upon Q naught. Now forever remember that the direction of field will be always along the direction of force. The direction of field will be always along the direction of force. Now from this expression also we can have that force can be taken as Q naught into E. We can represent force as Q naught into E. So what is this? This gives us the physical significance of electric field. That is, what is the use of electric field concept? So this helps us by this expression in identifying the force, its magnitude as well as its direction. See, when we say that force equals to Q naught into E, it means field intensity is because of some charge. Say this is because of any charge Q. So this is a Q charge, and at this point at a distance r we have this field intensity. If we have the field intensity along this direction, if we place any other charge Q naught at this point, so this charge will have the force Q naught into E along the direction of field. So at this point we get the magnitude of the force as well as the direction of the force on Q naught due to Q. This is the physical significance of electric field.